Good morning, everyone. Today, our investigation of density is going to start with a common trick question. Which is heaviest, 1 kilogram of bricks or 1 kilogram of feathers? I'm going to let you think about that. I hope you didn't fall for it and say bricks. The answer is that 1 kilogram of bricks is just as heavy as 1 kilogram of feathers. They both weigh 1 kilogram. But think, how big 1 kilogram of feathers would be in comparison to 1 kilogram of bricks. So I'm going to show you the picture. So there are a lot more feathers than there are bricks. So we're going to say density is the word we use to describe how much space an object or substance takes up, or its volume. So the feathers take up way more volume than the bricks. And then that volume is in relation to the amount of matter in that object or substance, or its mass. So when you pick up a brick, it's heavier than the feathers are. So this tells us that a heavy and compact object is high in density and a light and big object is low in density. The heavier and more compact an object is, or the more dense an object is, the more likely that that object is going to sink. So today we are going to look at a classic Montessori Casa material on the shelf. It is called Sink and Float. So we're going to be looking at different objects and seeing which ones sink or float. So we're going to get into our scientific method. And so our question is, what objects are going to sink and which objects are going to float? And I will give you a list of what objects we're going to be doing, and you'll see them as we put them in. And the next is doing some research, so we can research the materials and see which ones have more and less density, and we can figure out which ones we think are going to sink and which ones we think are going to float. Then we devise a hypothesis where we make an educated guess to think about what we are going to do. Then we set up our experiment where we get all our materials and we perform the experiment, and then we do our observations where we note which ones sink and which ones float. And finally, we write our conclusions, which are saying whether or not our hypothesis is correct. All right, let's get into this experiment. Okay, so now that we're set up, we're going to start with our first one, which is a cork. This cork is not too heavy and it takes up some space. So what do you think is going to happen when we put this into the jar? So I think it might float. So let's see if we're right. It did. All right, the next thing I'm going to do is a button. So the button doesn't weigh much more than the cork that just went into the jar, but if you notice, it's a lot more compact or smaller, so it takes up less volume than that cork. So let's see what happens when we put the button in. It sinks right down to the bottom. All right, we are going to do this paper clip. So it weighs similar to the cork, and it takes up similar space, but there's also not as much surface area like the cork. So let's see what's going to happen with the paper clip. Sink or float? Sink. All right, now we're going to do this fuzzy pom-pom. So I'm going to see what happens. So it's pretty light and it takes up some volume. So what do you think is going to happen? Sink or float? It's floating. Oh, but as it sucks up some water, it's changing the weight or mass of the pom-pom. And I think as we continue on with this experiment, I think the pom-pom might sink a bit more. All right, next we're going to do another type of paper clip. it's heavier than the other ones. And it doesn't take up as much space as, say, the cork does. So let's see what's happened. Sink or float. And it sunk. And it also caused the pom-pom to go down a little bit more. All right, next, I'm going to add this piece of tin foil. It's quite light and it takes up a bit of volume or space. So what do you think is going to happen? Sink or float when I put this in? It's floating. I don't know if you can see that. It's hard to tell, but it's hard to see on the top, but it's floating there up on the top. All right, next we are going to do this little eraser. It doesn't take up a lot of volume and it is a bit heavier, so it has more mass. So what do you think is going to happen? Sink or float? Sink. It also caused the piece of aluminum foil to fall because instead of being flat on top of the surface of the water, it made it go sideways, so it didn't have as much volume on top of the water, so it sunk down to the bottom. All right, next we are going to do a pine cone. So pine cone's pretty light, but it also takes up a lot of volume. So let's see what happens when we put this in. Sink or float? It's floating. And that pom-pom is floating towards the top, but it keeps going down a little bit further as it takes up more water and also as things bump into it. All right, next we are going to do this rock, which is kind of like the brick. So you'll have a pretty good idea of what's going to happen with the rock. Sink or float? Sunk. And last, we are going to do the feather. So I'm going to actually take out the pine cone to give it a bit more space. It's taking up some room. But let's put it in and see what happens with the feather. So it's light and it takes up more volume. So let's see. It is floating. And I don't know if you can see it, but it is on the top. Actually, I can lift it up. So now you can see what's happening on the top of the water. So that is sink and float. So the ones that have more mass, so that are heavier and take up less space, are the ones that are sinking. And the ones on the top are the ones that are lighter and take up more space. They're the ones that are floating on the top. So I'm going to add back the pine cone. So there's our floating ones. So we have the cork, we have the pom-pom, we have the feather, and we have the pine cone. And at the bottom, we have the eraser, the 2 paper clips, the button, the rock, and also the piece of aluminum foil, which would normally float, but because we changed what way the aluminum foil was facing, it sunk because it didn't have as much volume on the top of the water. It had a very, very thin piece, so it sunk down to the bottom. All right, now we are going to do another experiment that involves some chemical reaction and also density. So this is called an Alka-Seltzer lava lamp. So we're going to combine something that causes carbon dioxide to give off with oil and water. So water is more dense than oil. I'm going to turn this around so you can see it a bit better. So let's get into this experiment. So I'm going to add some drops of food coloring to make the water a different color. I'm actually going to add some more because I want this to be pretty bright so that you can really see what's going to happen. All right, next we are going to put oil and fill it up in this flask. I'm gonna let it settle for a minute so that you can really see what's going to happen. So now that we've let the water settle back down to the bottom out of the oil, I'm going to add the Alka-Seltzer tabs. So these are not something that you will use. This would be something that an adult, if you wanted to do this experiment, it would be with an adult because the Alka-Seltzer tabs aren't safe for you. They have acetaminophen and other medication in it. So this is not something to do without adult supervision. All right, now we're gonna put this tab in. And as it hits the water, it starts to bubble. And as it bubbles, do you notice all those oil drops moving up and down and around? So, the ingredients in the Alka-Seltzer tab combine with the water to form a gas called carbon dioxide. The oil and Alka-Seltzer do not combine in this way though. The Alka-Seltzer tablet sinks through the vegetable oil until it reaches a layer of colored water. There, the Alka-Seltzer dissolves in the water and forms a gas called carbon dioxide. The gas is lighter than the water and oil, so it bubbles up, taking a bit of the colored water with it as it moves through the oil layer. You should see those bubbles looking like colorful blobs floating through the oil layer up to the top of the jar. At the top, the bubbles burst, releasing the carbon dioxide gas, and then the colorful blobs sink back to the bottom. The effect is reminiscent of a lava lamp. So the chemical reaction that causes the carbon dioxide to form happens more quickly in warm water. So I'm going to add another tab to keep this going. So I chose this experiment because it combines what we talked about last week about chemical reactions and what we're talking about this week, density. So it's pretty fun to see. You see all the blobs come up? So that's the gas bubbles bringing the colored water up through the oil, and as the bubbles burst at the top, then the blobs of water go back down, back through the oil. Thank you so much for doing some experiments with me this week. I hope you enjoyed them, and I will see you next week. Bye, everyone.